Let's talk about how to make a meaningful sketch. Anytime you're given a motion problem, you want to extract from the motion problem all the meaningful information you can and leave out all the clutter, the stuff that really doesn't matter. And the best way to do that, and the way I'm going to often require you to do that, is to make a meaningful sketch. You could call it a meaningful motion sketch. What must it include? A frame of reference. You must indicate the initial position of each object. That's essentially when our scenario starts, when our stopwatch, our imaginary stopwatch, reads 0 seconds. You need to indicate the velocity of each object, and I want you to do it with speed. That's the magnitude, and an arrow on in your sketch indicating the direction of motion, and essentially nothing else. All right, let's look at an example to get started. Justin Bieber is driving in his new Tesla Cybertruck south on Hoquiam Avenue at 16 meters per second, about 35 miles per, well, okay, that's just background, 35 miles per hour. Justin is eating banana, humming old Elvis tunes, and wondering if the windows in his truck are shatterproof, as Elon Musk claims. A busload of adoring fans, mostly teachers at Hazen, is 75 meters behind Justin's truck and moving at 22 meters per second, trying to catch up to Justin before he reaches Sunset Avenue. An alien monster in a well-tailored suit is running south on Hoquiam at 6 meters per second, heading towards Justin. The alien monster, who wants to eat Justin Bieber for lunch, but only after getting his autograph, is 120 meters from Justin's truck. How far from Justin's truck will the busload of fans be when the alien monster reaches the truck and presumably gets Justin Bieber's autograph and then eats him? Woo! You ready to answer that question? I don't think so, because that's just a whole lot thrown at you. So let's extract the meaningful information. All right, so the first thing we need is a frame of reference. I'm envisioning south as this way and north as that way, because when I get onto when I leave Hazen, I drive north, and I always think of driving that way. So I'm going to say that, well, here's my frame of reference. I've decided which way is positive. I'm going to just say this way is positive because Bieber's going this way, the bus is going this way. I know the monster's going that way. All right, and one-dimensional motion, we're going to make that x, and we're going to have whatever numbers I put on in here are going to be in meters. I haven't decided where the origin goes yet because I want to kind of get things thinking here. Okay, initial position. So now what we're going to do is go through and extract where are these three things. Okay, Bieber is driving south, and okay, eating banana. Okay, that doesn't matter. All I really care about is where is he. Well, it doesn't say where he is specifically, but he says the bus is 75 meters behind him on this side, and the alien monster who's coming this way is 120 meters from Bieber. So I'm going to put old Biebs here, right here. Now, am I going to try to draw Bieber? No. I'm going to just put a letter. And I like to put boxes around my letters. Remember, nothing else other than motion information. I don't really care that this is Justin Bieber. Okay, but there he is. Now, once I say Bieber's there, then I got to say, where's the bus? The bus is 75 meters behind. So there's the bus. Am I going to try to draw the bus? No. Am I going to try to draw the adoring teacher fans? No. I'm just going to say there's B for bus. Could you just call this 1, 2, and 3? Absolutely. But I'm using J for Justin, B for bus, and where's the monster? Monster's 120 meters on this side. This is 75, so that's 120. It's not that important to make it to scale. It's more important, but I like to help me visualize. So here's the monster. Okay, so now you can put the origin anywhere you want. I can put the origin, but I'm going to put the origin here because that means these are all positive values. I tend to like positive numbers more than negative. Now, if the bus is at 0, where's Justin? Justin is 75 meters on this side, so that his position is going to be 75. So the bus, I put the bus at the origin. You don't have to do that, but I'm going to. Okay, and then now where's the monster? We don't want to just say 120 because the monster is 120 from Justin. So what's 120 plus 75? 195. Okay, these are all going to be in meters. Okay, so we've done our frame of reference. We've done our initial position. What about the velocity? Okay, so now we are going to extract what's Biebs doing. He's going 16 meters per second. Which way? He's going this way. What's the bus doing? The bus is going 22 meters per second. So I might even make that arrow a little bit longer because these really would be velocity vectors, but it's not that important, but I like to make the arrows a little bit longer if they're going a little bit faster. And now the monster is going 6 meters per second and going this way. So I'll make that a shorter arrow. That's our meaningful sketch. You know your sketch is meaningful if you no longer need to look. I do not need to look. There's no additional information in here I need to make my sketch graphs, my motion graphs, which we'll be talking about. I can get all my motion information here, and then my motion model, which is my position equation. I can get all that information here. So that's what makes a sketch meaningful. Everything you need to analyze motion is extracted. And even though it's kind of an interesting scenario, well, you need the question. I don't have to look back up here. That's a meaningful sketch.